Good morning or afternoon or evening, wherever you are. Thank you so much for joining us today for today's webinar, Lean Farming, Cutting Waste and Boosting Yields in Cannabis Cultivation. Of the topics that you can really never get enough of in cannabis, I would say this has always been one of the most important, but in recent years, it's really become a key to survival. So I'm super excited to be able to host this webinar today. I am going to start off with a joke. Some people have suggested that we start with some jokes to liven up what are some pretty intense topics. So I looked up jokes for lean farming and lean manufacturing, and there really are hardly any, shockingly. I would think there would be a ton. So here goes. If anyone knows the answer, feel free to type it in the chat. What is a lean manager's favorite movie?
What?
Thank you, Michael. I can't do it with a straight face. It's a sequel to an old classic, Gone with the Waste. But I had to do it. I tried. Anders, you liked it, you know it.
I loved it. I loved it. Really
So
broke the ice.
yes, I'm Noelle Skadinsky with Cannabis Business Times. In today's event, experts from PIP Horticulture will share with you how you can apply lean manufacturing principles to your cultivation operations. The webinar will show you how to spot and eliminate the 8 wastes of cultivation, streamline workflows, improve ergonomics, and adopt continuous improvement practices. I'd like to first thank our sponsor, PIP Horticulture, for making this webinar possible. PIP is the industry-leading provider of mobile vertical grow solutions with installations in over 3,000 grow rooms worldwide. I'm sure that number has been growing. With more than 40 years of experience, PIP has engineered a variety of cost-effective solutions that enable you to exponentially grow your production without increasing your square footprint. Before we get started, I have just a few housekeeping notes. If you've all been with us before and know all of these, just bear with me. But we will be leaving time at the end of the webinar for questions from you, our audience. So you can submit your questions at any time during the webinar. If you would, please just submit your questions in the Q&A box. You should see a box at the bottom of your screen that has a Q&A under it and a big question mark in the box. If you could submit them there so that our speakers can just see all the questions in one place, that would be great. Also, our speakers have graciously offered to create a blog post following the event that will answer any questions that we're not able to get to during the webinar. We do have a pretty high attendance for this webinar. We expect a fair amount of questions, so anything, again, that is they're not able to get to, they'll be sending that out to you following the webinar with answers to those. So you're also going to see 2 super quick polls pop up during the webinar. If you would please just take a second to answer those, we would greatly appreciate it. And finally, we will be recording this webinar. So if you have to leave at any time or you want to come back and watch it again later with all the great information that's in there, we will be sending out a link to the archived webinar probably within a few days, but definitely within a week of the webinar. So you should see the first poll popping up. If you could take that, that would be great. With that, I am pleased to welcome our speakers. I should say welcome back. We've hosted Michael and Anders quite a few times here. We have Michael Williamson. As the Director of Cultivation, Michael fuses his 14 years of commercial cannabis ownership and operational excellence to provide support and strategy for PIP's engineering and sales teams and client operators. Michael co-founded Greenhouse Industries in 2013, now a division of PIP Horticulture, and is an early pioneer in vertical farming. Anders Peterson is a seasoned professional with over a decade of experience in the cannabis industry. Armed with a degree in cellular and molecular biology, Anders has emerged as a leader in indoor cultivation facility design and operation. His expertise lies in integrating cutting-edge technology, data analytics, and precision agriculture techniques to optimize plant performance and product quality. As the director of horticulture at PIP, Anders collaborates directly with growers, owners, and construction professionals and has contributed to the designs of over 200 indoor cultivation facilities. Michael and Anders, welcome. It's always a pleasure to have you here. Um, and I'm now pleased to turn things over to Michael Williamson. Michael, welcome.
All right. Thank you, Noelle, for the warm welcome. And thank you, Cannabis Business Times, for hosting us. And I guess most importantly, thank you for all of you that took time out of your schedule today to be with us. We'll make it worth your while. So today we're going to be talking about the 8 wastes of cannabis cultivation in the context of melding lean manufacturing into commercial cannabis operations. The goal today, every action, movement, and minute in your cultivation facility should add value to the plant, the end product, or the customer. Everything else is simply some form of waste, and what gets measured gets improved. Lean manufacturing transforms industries from automotive to aerospace. When you apply those same principles to cannabis cultivation, you can cut waste, improve yield consistency, and build culture where every grower becomes a problem solver and not just a task performer. Anders is going to highlight the origin of the 8 wastes, which actually was originally 7.
Yeah, so before we dive into how lean applies to cultivation, and it helps to understand where this whole idea comes from. The concept of identifying and eliminating waste actually started in manufacturing, specifically with the Toyota production system. Go Toyota, I love my 4Runner. And it was developed by Taichi Ono in the 1950s and 60s. Ono, who's known as the father of lean manufacturing, outlined originally 7 key types of waste that were holding back efficiency on the factory floor. Things like defects, overproduction, waiting, transport, etc. And we'll go through all of them here shortly. Later on, Western lean practitioners added an 8th waste, non-utilized talent, to recognize that people's ideas and skills are just as valuable as physical production efficiency. So together, these 8 wastes are often remembered by the mnemonic downtime, which stands for defects, overproduction, waiting, non-utilized talent, transport, inventory, motion, and extra processing. And what's really cool is that these principles translate far beyond just manufacturing, like in a Toyota or automotive plant. Every cultivation facility is, in a sense, a living factory, and every process from cloning to packaging can be optimized in the same way. So our goal today is to show how these classic lean concepts fit into modern cannabis operations, helping you spot waste quickly, standardize improvements, and focus your team's time on what actually adds value to the plant, the product, and the customer. And so just as a quick kind of overview here, these are the 8 wastes we're going to dive into. And you can see it spells the mnemonic downtime, which really makes it easy to remember. And with that, we're going to start with number 1, which is defects. And Michael's going to take this one.
Yeah, we're going to use a handful of maybe new words to you and some new definitions. We're going to try and explain all those as well. I just sent Noelle an email because I was going to enter them into the web chat so you guys could reference them back as we're talking, but for some reason it's not letting me. So maybe she'll be able to do that. But nonetheless, the first form of waste is defects. So I think we all know what a defect is in life, but just to quickly define it here, defects are any errors or conditions that cause rework, delays, or yield loss, whether that be in the plant, the process, or the environment. In cultivation, defects aren't just about crop failure. They're about every small deviation that forces a team to spend time fixing instead of growing. So what would be some examples of common defect issues? Poor defoliation, leading to restricted airflow and uneven light penetration. We see a lot of people accidentally over vegging their plants. Sometimes they'll be growing into the lights, causing heat stress, phyto bleaching, and quality loss. Maybe it's putting what I refer to as a runt plant, not to be confused with the cultivar, but a weak or undersized plant entering flower that never catches up. And when these defects occur, it triggers rework. And rework in the lean realm is a form of waste. Rework is when you have to redo or readdress a process that should have been done correctly the first time to meet spec. It's a waste of time, labor, material, energy, etc. So what are some examples of some of the rework, in relationship to some of the examples I just gave? Late or corrective pruning, or worse, topping mid-flower, all of which creates rework, waste, and devalue adding and unnecessary stress. Mid-flower topping, which unfortunately I've seen my farms do it as well, though it might optically look better, the plant's going through like a hormonal whiplash. It disrupts oxen flow, diverts energy into wound repair, and increases the risk for pathogens. Another example of rework would be culling or destroying runts after flip. It's literally a pure waste of time, material, and canopy space. So, when you have a defect and then you have to rework it and you're like, oh, I've resolved it, you really haven't. A rework is usually a band-aid because you didn't do something right the first time. So, if we look at the root cause, to no surprise, what's the root cause of some of these examples I gave? The things you would expect: inconsistent training, non-standard SOPs, poor scheduling and misalignment between veg and flower readiness, no clear quality control checkpoints or definition of when a plant is ready to flip. So we wanted to highlight some KPIs. So you'll see a KPI on this slide. We were also given some feedback on previous slides or previous presentations that you guys want to see our math and our formulas. So we kind of put that here so you can plug it in appropriately on your own time. But for this one, I picked yield consistency. This is the real test of control. And we're going to look at it from a coefficient of variation, or CV. So a CV is a unitless measure of relative variability that expresses the standard deviation as a percentage of the mean or average. It allows fair comparison of spread across data sets with different averages or units. So from my experience, any grower can have a great harvest once. The real measure of performance, and I believe the hardest thing to do in cannabis, is to be consistently great. So it's repeatability, hitting that same yield, that same quality, and that efficiency week after week. This is where yield consistency becomes a defining metric. So this metric measures how much yields vary over time for the same cultivar. And when we say over time, we're typically looking for 5 to 8 or more batches. And so the formula itself is the control of variation equals the standard deviation divided by the mean yield times 100. So standard deviation is just a measure of spread that shows how far the average data point is from the mean or average. The lower the standard deviation and tighter the grouping, the more consistent the process. The higher the standard deviation you have more variation. And so to put things in perspective, if you're targeting a 5% coefficient of variation in this particular KPI, that's considered like world-class consistency. If you're at 5 to 8%, that's a very strong control. If you're in the 8 to 12%, it's acceptable. And if you're 12% or greater, you're unstable and you need to investigate the process and kind of chew up everything you're doing and figure out where do these instabilities stem from. So the example here is I have a mean or average yield of 71 grams per square foot. The standard deviation on my imaginary cluster was 1.58. I take the 1.58, I divide it by 71, and I multiply that by 100, and I get a 2.2 CV. So a 2.2 CV, as I mentioned earlier, that's world-class, excellent process stability. And what it means is the environment, the irrigation, the nutrient delivery, the labor, and all the performance is completely in sync. The tighter the CV, the more predictable your output, labor, and revenue become. So in the lean world, they have what we call countermeasures. So if I knew that I had some of these problems, what are some lean countermeasures that I could implement? So the first one, based off of the examples earlier, is to create a definition of done for flip readiness. So you're basically taking the subjectiveness out of it and you're really making it objective. And so when we define what's done, we use things like photo standards, height and structure targets, and clear data thresholds. These will help you understand this plant is ready to flip into flower. And I do understand that a lot of you are on really tight schedules, and sometimes the schedule doesn't allow you to do what's right for the plant. So I just want to acknowledge that. Now, another thing you can do is you can improve a veg QC or quality control checklist and sign-off process. So before plants get moved from whether it's from clone to veg or from veg to flower, you would verify the health, the size and structure, uniformity, and maybe also make sure that all IPM preventative treatments were completed before the transfer. So defects cost you typically about 3 times in labor and morale and yield. By making readiness visual, measurable, and standardized, you'll turn subjective decisions into predictable outcomes.
Okay. Thank you, Michael. And that was a good structure to kind of how we're going through this. Some common issues, rework, lean countermeasures to combat that, and in a KPI kind of example. That's what we kind of want to go through this presentation with. So for moving on to number 2, overproduction. Overproduction is one of the easiest wastes to overlook because it usually feels productive, which is counterintuitive, I guess. More plants, more rooms, more material. That just sounds like progress, right? But in lean terms, it's really just tying up labor, space, and cash without adding real value. In cultivation, overproduction shows up in a lot of different subtle ways. Keeping too many mothers just in case, mixing more nutrient solution you need, then having to dump it later, trimming faster than packaging or QA can process. Even redundant data entry is kind of overproduction. It creates more work that doesn't move the process forward. That's actually a real subtle one that I see quite a lot is people collecting data, not knowing then how to use that data effectively to make an informed decision, but they've just spent the time to collect that data. That's an example of overproduction. But two of the more common examples we see are over-cloning or planting beyond your canopy needs, and then starting more flower rooms than your dry room or trim team can handle downstream. Like when you overclone, you're spending money and labor on plants that will never make it to harvest. It crowds your space, can complicate irrigation, and this usually stems from a belief that more plants is better or more plants equals more yield. But most commonly, it's you start off with this old overage or buffer mindset to have sending only the best and healthiest plants into your flower room. But then once your rooting success gets better and your overall cohort of plants and veg all has high health and vigor, people don't recalibrate as these success rates improve. And so they need to minimize that buffer or overage. So, right as rooting consistency and SOP adherence increases, those old 15 to 20% buffers can and should be reduced. This is a form of overproduction. And when you start more rooms than your downstream can process, you end up bottlenecking everything that follows. So drying, trimming, QA, packaging, that's when you start seeing rework, quality loss from under drying, overtime labor, and inconsistent results between batches. So the root cause of all of this is usually poor planning and a lack of coordination between teams. Veg and flower are often operating on their own schedules instead of one shared cadence. The fix is aligning production with actual capacity. And the KPI shown here is an example of that. Just use your plant utilization rate to track it. Plants needed for flips divided by viable plants on hand. Pretty simple math, pretty simple formula, but we often don't see people keeping track of this, really fully understanding how many clones were cut and how many sent to flower. If you need 720 plants but have 800 ready, that's a 90% utilization. And as Michael was talking about earlier, there's a fine line between like a safe buffer and just too much overproduction. I think a 2 to 5% buffer is healthy in this example, but anything more means wasted effort and materials. Some lean countermeasures here are simple but powerful. Using a Kanban system for cloning, so cuts are only taken when the next step needs them. Another example would be a flip gate checklist to tie each room start to available drying and trimming capacity. And a flip gate is essentially a go, no go kind of criteria that you set to say these criteria need to be adhered to before we move this process forward. And then sync everyone together in weekly planning meetings so you're all working from the same playbook. Overproduction is the enemy of flow. I kind of love that quote. It creates a false sense of abundance, but hides the real inefficiencies in your process. The takeaway is more isn't always better. When production matches real demand, you free up space, reduce chaos, and give your team more time to focus on quality. And that leads right into our next waste, which is waiting. Because even with the right amount of production, wasted time between stages can quietly eat into your yield and efficiency. Okay, so once production is right sized, the next big source of waste is waiting. Plants, rooms, or people sitting idle while the clock keeps ticking. In cultivation, one of the biggest examples is rooted clones being held too long before transplant. Maybe the vegetables aren't cleared yet, or the next flower room isn't ready. Those trays sit for a few extra days. Roots can get bound, plants get stressed, and by the time they move into veg, they've already lost that momentum and vigor. It doesn't sound like much, but stretched across multiple rooms and cycles, those small delays add up to a real yield loss. One of the other big ones is room downtime. When a flower room sits empty between harvests, waiting to be cleaned, repaired, or flipped, sometimes you're waiting on maintenance or spare parts. Other times it's just poor sequencing between harvest and reset. Every idle day is a lost production time. And in fact, I have a couple examples right now with customers of ours who are dealing with that exact scenario where they're doing a room upgrade or retrofit, and maybe they didn't schedule all of the processes in a way that they can meet their timeline. And right now, there's a few growers who are having to extend that empty idle room time, and it's really cutting into their bottom line. So this is a real world example. And this is also exactly why we like to track room downtime percentage on an annual basis. So how many days out of the year was your room idle, not actively growing plants, divided by 365? So if a room sits idle for 30 days a year, which is, I would say, not unheard of, but not super common, hopefully, that's an 8.2% downtime in that room per year. That's a full month of lost production capacity per room, and tightening that number by even a few days could turn into an extra harvest a year. So there are other forms of waiting too. Trimmers waiting on QA to release product, teams waiting on lab results. But one of the interesting ones to me is operators or employees stuck waiting on a decision to be made before they can act, like waiting on a decision from higher up. So every one of those pauses slows down the flow and chips away at efficiency. The root causes are usually pretty simple. Poor coordination again between departments, weak scheduling, or not having materials pre-staged. So some of the lean countermeasures and fixes, um, hold a short weekly sales and ops meeting. Michael actually has a great one with a few teams where he does it in the hallway every week and has everyone updated and synced up for the week ahead. And this just allows cultivation, post-harvest, and packaging to all stay aligned on flips and harvest timing. Another good fix is use kitting to pre-stage all tools and materials for daily tasks. So no one's standing around waiting for supplies or running around looking for things. And then finally, cross-train your staff so they can flex into prep or sanitation when things slow down to reduce the amount of waiting they're doing. And finally, stock critical spare parts. So one broken pump doesn't take down a whole room. That's something I think a lot of facilities could benefit from is more spare parts on hand. The bottom line to all of this is plants don't like to wait, and neither should your process. Reducing idle time between rooms cycling, it keeps people productive and yield consistent. And once you've got that flow dialed in, the next big opportunity isn't about plants at all. It's about the people running the process. And that brings us to non-utilized talent.
Sanders, you said a lot of stuff that kind of tugged at my heartstrings there, but all right. So yeah, non-utilized talent. This was the eighth waste that was added by Western lean practices. So what does that mean? It says here, listen to your people. I say listen to your people, but you don't always have to act on what your people say. But it's good to get all information, slices of pie on the kind of information chart there. So non-utilized talent is one of the most overlooked wastes in cultivation. It happens when you underuse your team's skills, creativity, and problem-solving power. In lean terms, and I love this, it's a waste of human potential when the people closest to the work aren't given the chance, tools, or trust to make it better. So some common issues here, growers and techs, like cultivation techs, are excluded from planning. Leadership makes a plan and the team simply just executes. Ideas from staff are ignored or never followed up on. I'm sure if you're in operations, that one probably really hits for you. No ownership of small continuous improvement. So when these types of common issues happen, a lot of things kind of roll downhill from here. Engagement drops, employee turnover rises, invaluable frontline knowledge stays untapped and kind of trapped. So what happens when we have to rework? And when we talk about rework is not a positive thing. Rework is additional waste. It's a form of waste, right? So rework in this examples would be repeating the same avoidable mistakes, over engineering processes that a grow tech probably could have solved in a simplified in 5 minutes, fixing the same reoccurring issue because no one has addressed the root cause of the issue. So let's take a look at some of those root causes. The root causes in these particular examples given is we have a top-down culture that rewards compliance over creativity and solutions. There is no structured feedback loop and ideas vanish into the ether. There's a lack of Kaizen. And I think a lot of people know Kaizen, but just real quick, Kaizen is a lean philosophy and practice of continuous and incremental improvement by everyone every day. Instead of big disruptive project, Kaizen favors small, fast changes that compound into major performance gains. But essentially, people that have a lack of Kaizen cadence or a visible idea board to track and celebrate small wins. So when I define this non-utilized talent, you're essentially measuring how much a KPI improves. Oh, sorry, I'm backing up. The KPI we like to look at here is post-training performance delta. So a lot of people are like, oh yeah, I was trained on that once. And then it's like a one-time event. And in the lean mentality, they were incentivized back at Toyota, not at so much achieving their goals, but more so how often an SOP changed and evolved. Because if a company were to change the SOP or evolve the SOP, that meant that there was an improvement to the SOP. It means that something was made leaner, smarter, faster, better. And so when you train someone, you should be measuring your post performance of that training. Did the training work? I mean, maybe you gave someone a training and maybe it made it actually worse. So you can kind of flip this and inverse it a little bit. So this particular KPI, the post training performance delta, it measures how much a KPI improves or worsens after employees complete a specific training module. It shows whether the training actually changes performance on the floor. The formula we use here is very simple. It's a percentage-based delta, and it equals after training KPI minus before training KPI, and you divide that by before training KPI, and then we always multiply by 100. So why does it matter? Well, you start to turn training from a cost into a measurable investment. It identifies which training modules, trainers, or formats are actually improving performance. It also reveals where standard work isn't sticking and where additional coaching or SOP refinement is needed. So I'm going to run you through like just a real quick method on how to run it. You choose one KPI directly tied to the training objective. So one module, like one training module equals one KPI. You establish a baseline for 2 to 4 weeks before the training with stable staffing and scope. You then deliver the training after you've done that, taken that data set. You deliver the training and document who attended, when, and what version of content was used. You then track that same KPI for 2 to 4 weeks after the training. This allows you to calculate the delta percentage, and then you quickly share that results with your team. A lot of people, they'll train their team on what to do, but they won't explain to them the why. The more transparent you are with your team on why we're doing something with the goal of improvement, the more they can sync up with the general kind of mindset of the company. And then from there, you lock in any changes, that sustained improvement, and kind of rinse, lather, repeat. So a quick example here, canopy training and defoliation standard. The training goal would be standardized early flower defoliation and canopy training to improve light penetration and airflow. I know at our farms, we're consistently chasing this. Depending on who does what, there's slight variations and deviations in between each of the workers. And so we've always been trying to work on defining that company's spec procedure and get everyone kind of doing things the same and generally in the same timeliness. It's sounds easy, it's very complicated and challenging to do. But the KPI here again, yield consistency. So we're looking at a coefficient of variation for an affected cultivar. I'm going to baseline, so this would be the before, and let's say my coefficient of variation was 9.5%. After the training, the CV dropped to 6.6%. So I then take that, I look at the delta. I look at 9.5 minus 6.6. I divide it by the original 9.5, which equals 30.5% improvement. And remember, a lower coefficient of variation is better. So if I were to interpret that particular example, it tells me that variability dropped by about 30%, leading to a more consistent yield in this case. So as we talk about lean countermeasurements, what are things that we can do to utilize all this talent? We can do weekly huddles for idea capture and fast feedback, and simply create a 10-minute morning stand-up meeting where staff shares pain points or small improvement ideas. You can post them on a visible idea board, assign them to an owner because everything needs to have ownership and accountability. And then you would test the best ones quickly. And we do in lean what's called a PDCA. So plan, do, check, act. We do it in real time. And a PDCA is just a very simple cycle for continuous improvement. You plan a change, that's the P. You test it on a small batch, that's the do. You check the results with the data, that's the check. And then you act on it. So you either standardize the win or you adjust and try again. Another lean countermeasurement is what is referred to as A3 problem solving. So A3 in lean is a one-page problem-solving method that guides teams through clear thinking, defines a problem, graphs current conditions, finds root causes, chooses countermeasures, will run a PDCA, and then it'll lock in that control. And honestly, it's less about the paper and it's more about the discipline and the visual reasoning and alignment that it creates within your company. So I know we're talking about it sounds like we're talking about a lot of paperwork, but this isn't about paperwork. It's about ownership and learning to think within systems. If there's a key takeaway I want you to be thinking about from this one, it's that the people doing the work see the waste first. They just need permission and structure to fix it. When you create systems to listen, measure, and act, your employees evolve from operators into problem solvers. Your culture transforms from reactive to proactive. Lean isn't about doing more with less, it's about doing more with your people's best ideas. All right, on to our next slide, our fifth form of waste, which is transportation. Too much moving and not enough growing. You know, depends on your scale, but people don't realize, and I encourage everyone, Anders' favorite tool in the garden is a tape measure. We have like $40,000 kits worth of tools of all this really complex stuff that we'll use for analytics from time to time. But then at the end of the day, we're using a $10 tape measure. And my favorite tool is a stopwatch, which I like to use the phone because of the lap feature. Because the lap is like, okay, someone just transplanted a plant, lap, lap, lap. So we use very simple tools here, but I encourage everyone to start doing some time and task management. So transportation, what does it mean? It's an unnecessary movement of materials, plants, or products that adds time, risk, or fatigue without adding any value. So we kind of think about touch points and movement as either value adding, and I want to define that. They're adding value to the end consumer, not adding value to you out of convenience of what's best for you. And then there's devaluing touch points as well. And those would be things that devalue the product that the end consumer receives. We're always with lean, we're always putting the end consumer as kind of the North Star. So every extra trip or touch point increases handling time, contamination risk, and an opportunity for damage. Some common issues, and some of this you can control and some of it you can't. But this first one is long travel paths between nursery, veg, flower, and waste areas or drying rooms. And a lot of that you might be pigeonholed a little bit because you weren't involved in the design process. If you're designing a facility, that comment is specifically for you. There is what we call the path of the plant. It starts here and it ends there. You want to design in a linear flow that aligns with the path of the plant that it's naturally going to take. So you're minimizing how many steps, how many touch points, and how far plants have to travel on their pretty quick journey of life. This one really hits for me. This one's back and forth trips for tools, media, nutrient tanks, scales, whatever it might be. The amount of time that I observe people, and I don't want to say wandering around, but it is. They're looking for something. They're searching for a tool. And one of the things that drives me absolutely bananas is when someone can't doesn't have the tool they're looking for. They get off task, they look for it for a little while, they realize they can't find it, and then what do? They go interrupt someone else that's working and say, "Hey, have you seen the ladder? Have you seen the chickamasas? Have you seen the whatever it might be?" Then you got two people off task, and that second person sometimes will get up and wander around and look with them because they're trying to do the right thing and help out a peer. But at the same time, because your tools weren't kitted well and not in close reference point or in like good visual aid, you're going to wander around these facilities. And some of these facilities are a little bit of labor labyrinths. One of the other common issues is operators walking excessive distance to complete simple tasks, which correlates right into this as well. So a real world example, at one indoor facility, staff were walking nearly 4 miles a day, simply fetching tools and media. Time that could have been spent on plant care. After reorganizing the workflow zones and introducing mobile carts, they were from PIP, I will say. They cut walking distance by 40%, and they gained 2 extra labor hours per shift. That is monumental in time savings and productivity. So what's the rework look like? Well, if I have to go wander around, I've got extra handling. It could cause plant stress, breakage, or even cross-contamination, delays from misplaced tools or staging congestion. And what are the root causes? Poor facility layout, lack of defined one-way flow, like I talked about briefly earlier, no kitting system, or one of my favorite terminologies in lean manufacturing, which is water spider.
He's not kidding. That's his favorite term. When we were prepping for this webinar, I think he said the word water spider 100 times on a call. He loves that term.
Yeah. And so, for anyone that's not familiar with the concept of a water spider is a dedicated support operator who circulates on a fixed route and cadence and delivers fresh materials, collects unfinished work, and resets workstations. You can kind of think of them as like the pit crew for your cultivation team, ensuring that growers and trimmers stay focused on value adding work and not logistics. Um, and so one of the top KPIs that I like to look at is handling touch points per batch. I was working up in Canada 2017 to 2020 pretty aggressively, and I was working on a large 1.4 million square foot greenhouse, and I just counted how many times and it was very highly automated. It was an extreme, cannabis facility, but through all this automation, the plant once it was harvested it went to 21 different bins. And so we thought we had full automation. This is about as lean and mean as it gets. And all we had was degradation of the plant and all these unnecessary and devaluating touch points. We ended up reworking the entire lines over a 9-month period, and we reduced the 21 touch points down to 7. And so one of the things that you've got to be kind of thinking about is why am I touching this plant? And do I have to do it? And so you should kind of question all this stuff. And one of the things I like to do is I like to use a sticky pad of notes. And for every touch point, it doesn't matter if it's in post-harvest or cultivation, you just go through the process and you say, okay, I touch it once, put a sticky note on the wall. I touch it twice, sticky note on the wall. And you line up all your sticky notes. And then you look at each one of those touch points and you say, how does that add value to the end customer? If you cannot come up with a clear answer, it should cause you to pull that sticky note down and reevaluate if you need to even do that process at all. And is it possible to skip that process? And a lot of times it is. So the formula is really straightforward. It's just counting touches from step A to B. So the example is I go from a drying rack, I then go to bucking, I go to cure, I go to sort, I go to trim, I go to pack, I go to label. That's 7 touches. So, if I were to analyze that, I know there's some nuance in between, but that's like pretty standard and kind of moderate. There's probably opportunities with some creativity to reduce some of those touch points and tighten up the layout. So lean countermeasurements, we talked about it a little bit at the beginning, designing for one-way flow, organize your room and your pathways so plants and materials move forward only. You don't want to like double back on yourself. There's risk for contamination. Like you wouldn't want to go from propagation to drying to veg to, you have a path of plant. You want to go from basically propagation to the end result is packaging without crossing or back tracing. Mark travel lanes clearly and use staging zones to prevent congestion. Anders mentioned this earlier, implementing kitting. Kitting is just what you think it is. It's a kit of tools. So for some people, that might be a strategic kit of buckets. What I like to do is I like to get like a U-line or PIP cabinet on wheels, locking cabinet, and I put all the tools in there and we physically roll that to where the work is happening. Instead of someone having to go, I don't know, 1/8 of a mile around the other side of the building to go get replenishment on something, everything you need for that process or task is right there at your hands. We talked about the adding the water spider a little bit. I won't get into that. Another opportunity you can do to countermeasure some of this stuff is you can apply the 5 S's. The 5 S's in lean are sort, set in order, shine, my favorite one, standardize, and sustain. A lean workplace organization method to keep tools and spaces efficient, safe, and ready to use. And then the last one is a shadow board. These are wall mount boards with tool outlines. You can kind of think of this as like, I bet 50% of your father, your grandparents, your grandfather probably has that cork board in the garage and it has like, here's where the hammer goes and they draw a Sharpie marker around it. You know that hammer's missing if you're not using it and it's not in its home. And so each tool that you use on a regular basis needs to have a dedicated home. And if you have a dedicated home, you'll never have to look for your tools again because it's either in your hand or it's in its dedicated home because it's unacceptable for it to live anywhere else. And then any of these boards and things that you would mount, you always want them to be like ergonomic, so eye level. Someone from, let's say, 5 feet tall to 6 feet tall should be able to easily see and reach these tools. So every unnecessary move is a form of invisible waste. Once you map out your flow and measure how often items are touched or moved, you'll see hidden inefficiencies that can easily cost hours a day. Tightening your flow and implementing kitting and water spiting systems can free up 10 to 20% of your team's time without adding a single person.
Okay.
Sorry, I was long-winded.
Number 6, inventory. The next waste we're talking about here is inventory, or what we like to call cash sitting on a shelf. And so, by definition, this means having excess inputs, work that is in progress, or finished goods that tie up money and hide problems. In a cultivation facility, that usually looks like pallets of nutrients, pallets of substrate, packaging, or even excess mother stock that's way beyond what's actually needed for the next couple of weeks or cloning events. It feels safe to have extra. I know I have definitely fallen into this trap. But in reality, all of that product represents tied up cash, wasted storage space, and higher risk of things going bad or becoming obsolete. And I think that's an important one. I know in times of stress, like let's say if I'm facing a certain pest, I go overboard buying IPM products because I feel like I just need to have all of it on hand and a bunch of it, all the tools in the arsenal. I end up not using some of it. it sits on the shelf, and by the time I need it next time, it's expired and I can't use it. So I've just wasted that entire purchase. Um, and so this is really a very common example is overstocking inputs. Uh, Maybe you just got a deal on nutrients or cocoa coir or some other substrate. So you ordered enough for 3 months instead of one. The problem is all those materials now sit tying up thousands of dollars. And meanwhile, your team is typically having to spend extra time working around that excess inventory that you've purchased and restoring. So moving it, tracking it, and managing that extra inventory. Um, the root causes here really come down to a lack of clear par levels, poor communication between purchasing and cultivation, or which is understandable today, not trusting your supply chain. Uh, and one thing I see all the time is that no one is actually assigned to handle ordering at a lot of these facilities, especially in the smaller to mid-scale facilities. That task of, hey, I need gloves, I need isopropyl alcohol, whatever it is, it gets passed around, or people just place orders when they notice something is low. There's no real system in place. So every facility really should have at least one dedicated person, even if that is a part-time job for that person, responsible for managing and ordering the supplies. When that role isn't clearly defined, confusion sets in and things get over ordered or missed entirely. And this, again, these all kind of tie together. If you miss ordering something, it goes back to the previous one I spoke on, which is waiting. People sitting around waiting for a spare part or some other key ingredient to the process. So the way to keep this in check, just a simple kind of KPI, is tracking days of supply on hand. And I think it's a good exercise for a lot of people to go through. Maybe start with the FERT room, for example, because you're constantly going through consumables there. Um, the formula is simple. It's on-hand quantity divided by average daily usage. Uh, for example, let's say you got 1,800 liters of nutrients in stock and you use about 60 liters a day, that gives you 30 days of supply. So that's an example of like a par level and a month of inventory without going overboard. And it may sound comfortable, but it might be more than you need. Just depend on your usage and how much you can store. The goal is just to keep enough on hand to cover your lead times plus a small safety buffer. So it's a good exercise. I challenge you to try that with at least one consumable product in your facility. A few lean countermeasures. Again, setting clear par levels. Again, you can use that simple Kanban system for reordering, so materials are only replenished when they hit that trigger point. And just do regular counts. Keep up with your inventory. A key takeaway here with inventory is that every extra pallet or barrel represents money that could be working somewhere else in the business. When inventory is lean and visual, and when someone owns the ordering process, you free up cash flow, space, and focus for the things that truly add value, the plant and the product. And speaking of flow, the next big waste we'll look at is motion. All these extra steps, reaches, and lifts that wear your team out without adding any extra value.
All
Okay.
right, motion. Yeah, work smarter, not harder. All right. So excessive and inefficient human movement. This could be walking, bending, reaching, lifting, twisting, jumping, whatever it might be. But these things add time, fatigue, and injury risk without adding value. Every extra step is wasted energy that reduces productivity and increases ergonomic strain. Common issues here, reaching over deep benches. Some people go for the 5 foot wide, but not a lot of people have the wingspan of Conor McGregor and aren't able to reach the inner side of the canopy. All these things add strain, risk. They can even decrease morale because people are, it's just those little subtle overreaches that can lead to real pain points. The constant back and forth for tools, pots, or irrigation fittings, handling media or waste or trellis material more than once. So here's a real world example. Indoor cultivation facilities, cultivators are walking over 10,000 steps per shift, primarily retrieving tools and materials. After they implemented the 5S organization and mobile work carts provided by PIP, average steps dropped by 45%. saving 90 labor hours per month and reducing operator fatigue. So the rework, the labor waste there was it was slower task performance and declining quality near end of shift. We also saw an increase in employee turnover rate because people were like, you know what? I don't want this. This job's not worth it. I don't need to feel this way. I can make more money and, sit in a comfy chair. Increased risk of ergonomic and injuries and downtime. We look at the root cause on that stuff, and a lot of it's cluttered and unstandardized workspaces. One of my favorite lean concepts is and I use it at home with my children, but we call it returning your space to zero. And essentially, if you have a cluttered workspace, you're going to have a cluttered workflow. You're also going to have a slower workflow. So sometimes if I'm in a certain department or manufacturing or cultivation, and I see that like it's just a mess, I'll have them stop and return their space to zero. You literally take 2 to 5 minutes max, and you just get all your tools right. You get everything positioned right. You clean and clear it up, and then you start over. You typically are returning your space to zero if you're not doing it midway. You would do it when you take a break at lunch, let's say. So you come back to a clean and organized space. And then you would be doing it at the end of the day, essentially, to set up the next day for success. Um, Let's see, root causes, poor workstation design and fixed height benches, no lift aids. If you have the ability to have ergonomics where you can adjust the height on some of these workstations, that's really helpful. As no crew has the exact same height of people. Lack of rotation between repetitive or high strain tasks. If you have someone doing like the heavy lifting all the time, it's important to cycle that person out and do some cross training. So the KPI that I like to look at here is labor hours per pound in cultivation. Pretty straightforward, measures direct cultivation labor time required to produce 1 pound of finished dry flower, nursery through harvest. The formulas up here on the board, I can't see that small right now. My eyes aren't that good. We've got total cultivation hours divided by finished dry pounds. I mean, it doesn't get any more simpler than that. But in this example, there's 720 cultivation hours, and it was a 480 pound yield. So you're at about 1.5 hours per pound. And then you can look at what you charge for your hourly rate and kind of analyze that. But the analysis on something like that, this is a pretty solid baseline for an indoor facility. It's best in class operations are averaging 1.0 to 1.3 hours per pound. So this one's just a little bit over that. There's probably some opportunities to reduce some motion waste through layout optimization, ergonomic design, and standard workplaces. Um, and then I guess my key takeaway here is little steps add up to pretty big dollar amounts. And so if you can start to time these steps in these different engagements, you can save big dollars pretty quickly. And this is something you can do tomorrow.
Okay, our last but not least of the 8 wastes, and apologies for going a little long. We will try and get to as many questions as possible here. But to kind of touch on our last waste here, extra processing. Um, and as we like to say, don't overdo it. I mean, I think there's a lot of that in cultivation. This waste can show up anytime we do more work than is actually needed to meet the spec. It usually comes from unclear standards or low confidence in our controls. So we compensate by adding extra steps just to be safe. In cultivation, two of the more common examples we see is one simply just overwatering as a pretty simple example, but it's prevalent throughout the industry. And then oftentimes excess defoliation. So overwatering or overirrigation often happens when people are chasing perfection or without real data. They water more frequently than necessary because they don't fully trust their substrate sensors. And a lot of people are just afraid of underwatering. The result is wasted water, nutrients, and labor. In some cases, weaker root development or nutrient imbalances. And the same goes for defoliation. Teams will keep going back into the room late in flower to clean up leaves, but that really don't need to be removed. And so that's just extra work that just adds labor hours and plant stress. Usually this is all overwork. Concept is caused by fuzzy standards and a lack of confidence or lack of training. When done isn't clearly defined, as Michael had mentioned earlier, everyone has a different opinion of what good looks like, and that leads to wasted effort. You can see the example here. I'm going to go through it. I'm just going to kind of let you see that. It's a simple one just to save a little bit of time. But to kind of touch on our lean countermeasures for extra processing, my favorite one that I found use in is defining done, especially for these subjective steps in the process. So visual cues, pictures, videos, and continually reminding the staff what done looks like as a team so everyone's on the same page. So takeaway from this one, more isn't always better. Every extra gallon of water or unnecessary leaf that you remove adds cost, labor, and variation. When you define what's truly critical to quality and trust your systems, you work smarter, not harder. And that's what really lean is all about.
Nice.
Okay. So,
All right.
whoops.
Yeah, we'll
Yeah.
just wrap it up real quick here. But yeah, starting small, focus on one waste per month. Ask, does this add value to the plant or to the customer? Use visible KPIs that the team can track and get them into that mindset. It really is a mindset, and all of a sudden you're running like a department based off of data-driven decisions instead of like emotions and gut feelings and all that other stuff. When a better method works, standardize it. Repeat continuous improvement is ongoing. So lean is not really about working harder, it's about removing the obstacles that prevent great work. When you reduce waste, you unlock time, energy, and quality that drives profitable cultivation. On that note, we ran pretty tight, but we've got some time for some Q&A. If we don't answer your question, we do provide a blog, usually a week or two afterwards, that we put on our website. It'll get emailed to you, I believe, as well. But Anders, you cannot see the questions, right? So I'm looking for questions for.
No, but I just wanted to add one note here, kind of before we jump into that, is lean. There's a lot of concepts and a lot of information introduced in this, and we touched on a lot of key terms and acronyms. There are certification programs you can go learn and take online and in person at different universities, websites to be certified in these concepts. So it's kind of its own language. I highly recommend if this is a topic interesting to you. Look into these certifications and learn more about it. It's very
Cool.
useful.
All right, first question, nice easy one for us. It was a problem, and so we addressed it from a manufacturing standpoint. But the first question is from Michael. Thank you very much for your question. Great name. How do people defoliate on a second tier while keeping plant matter from falling on the first tier while maintaining operational efficiency? Um, that right there is what inspired us to create the Elevate platform system. It's you're not on a ladder, you're on a standard solid ground floor, and so it's really no different than if you were defoliating on the first tier. When it comes to like I'll just put a little lean spin on it. I like to watch individual workers and how they defoliate, and it's fascinating, and I encourage everyone to do this because you'll see these subtle differences. And the major one that I see is some people will pick like two or three leaves off and they'll put them in like maybe a 5 gallon bucket or some other type of receptacle. The best defoliators I see, they're defoliating usually with both hands and they or one, and they'll store like 50, 60 leaves in one hand. They'll just bunch them all together and then they'll drop them in the bucket. And it might not seem like a big deal, but when you're timing things, that 2, 3, 4, 5 leaves bucket, you just lost a second. 2, 3, 4, 5 leaves bucket, you lost another second. And so that person that does 50, that's just defoliating and just storing them in one hand kind of thing, they're usually saving they're like 20% faster on average. But yeah, that was the inspiration for our Elevate platform system. If you're not familiar with it, you can learn all about it on our website. Um, the next question, how often should one use PDCA? So plan, do, check, act. PDCA is meant to be quick. And so also you can have your own team set up these plan, do, check, acts. And these are for like how often? As often as you have the time to do it. And making the time to do it will help drive decisions in your facility that allow you to kind of say like, we should move forward with this or we should not. That's kind of the whole purpose of Plan, Do, Act, Check. It's like, okay, we have an idea. Let's test it out real quick and then let's assess. And if it checks out, then you might be changing an SOP or a work instruction. So PDCA is something that you can kind of roll out quickly once people understand the concept. Anders, do you have anything to add on that one?
No, I think the important thing there is just do it as much as you can. It doesn't take very long to do.
Okay. And then let's see, from Joseph here. Someone who's familiar with Toyota way of non-manufacturing cannabis business. I'm assessing feasibility. Okay. Do you have advice on where to find additional resources in this topic? I'm in a state where I have few contacts in the industry, potentially significant opportunities, but knowledge vacuum, offline responses are okay too. You know, we decided to pick this topic because we don't hear people talking about it. And you know, the beautiful thing about lean is once you understand the core principles, it is a universal language across all business. And Anders knows my personal life pretty well, but I use lean in my personal life. I'm kind of a minimalist. So I've brought lean into my household. I think I mentioned earlier about returning your space to zero. When my kids are just making a mess and they're kind of frustrated and stressed out, I'm like, whoa, whoa, whoa. But you know, we can finish this project, but first let's return our space to zero. So for me, I think lean is like a universal language. And as far as more information, Joseph, if you want to reach out to us, I think one of the polls was if you want to get some one-on-one time with Anders and myself, you know, sign up for it, and we'd love to chat with you more about it. And it sounds like you might have few contacts in the industry, but you have two new ones as of today. Um, any other questions that I'm missing? I don't think so. Let's see. Just going through the webinar chat. I think we're good. I think that concludes today's webinar. I just want to say again, thank you so much, CBT. Thank you, Pip, for always allowing us to have these educational platforms. Anders, it's always a pleasure to work with you. And the next webinar we're going to do, which I don't know when the date is, it's going to be this same topic, but focused on post-harvest. So we look forward to joining you then. And until next time, have a great day, and we'll talk to you soon.
Thanks, Michael. Thank you, Anders. Thanks, everyone, for joining us.
Thank you, everyone.